We are now on Chapter 4, Networking Media, and this is another very short chapter. In this chapter, we look at connecting computers. We look at types of cabling, and we look at wireless technologies. There are essentially two methods of connecting computers, using bounded media and using unbounded media. Bounded media means using wires, and unbounded media means using wireless. In wired networking, we have three general types of networking: twisted pair and coaxial, and they are both made out of copper, and fiber optic cabling. This is a twisted pair cable here, and it just looks like a regular old Ethernet cable. It doesn't look twisted to me. But if you cut the cable open, you see it has 4 pairs of twisted wires. That's why they call it twisted pair cabling. And the types of connectors that you will see with twisted pair cabling are RJ45 and RJ11 connectors. We use RJ45 connectors because this is used for local area networks. An RJ11 connector is what's used for a telephone line. They look similar, but when you put them side by side, you can see that the RJ45, the Ethernet jack, is a much wider connector. The cable which connects the computer to the switch is called a patch cable. Sometimes they call it a patch cable, sometimes they call it an Ethernet cable. And we have straight-through versus crossover cables. A straight-through cable is just a regular old patch cable. It connects the workstation to the switch. Now, a crossover cable is a special purpose cable. It's typically only used when you're doing a direct PC to PC connection. Almost all of the time, you will be using the straight-through cables to connect PCs to the hub. But sometimes when you need to do a PC to PC connection, you use a crossover cable. And if the network interface card is auto-detecting, it doesn't matter what kind of cable you use, crossover or straight through. What's the difference between shielded and unshielded twisted pair cabling? This is the unshielded twisted pair cabling. The shielded twisted pair cabling has a foil sheathing. It looks like aluminum foil, which is wrapped around the cabling. And the purpose of that is to give it greater protection from electromagnetic interference. Here's a picture of a shielded twisted pair cable, and you can see there is the aluminum cladding, which gives it a little more electromagnetic protection from electromagnetic interference. Of course, it's thicker and it's harder to work with. Plenum cable is twisted pair cable, which is heavier duty and it is fire resistant. Another type of cable we use is called coaxial cable, and you frequently see that if you have Comcast, and that's what's used for cable TV. If we cut open a coaxial cable, we can see it really has 2 wires in it, a wire down the middle and then a tubular wire that goes around it. They call it coaxial because both of these wires share the same axis. If we cut open a coaxial cable, we can see that this is the sheathing, the cladding on the outside. This is our braided copper shielding. This is plastic insulation, and this is the copper core in the middle. The types of connectors that you use for coaxial cable are BNC and F-type connectors. The BNC connectors are typically used with the old Ethernet 10-base-2, and the F-type connectors are what you see with cable TV connectors. Coaxial cables can go a longer distance than twisted pair cabling, but then again it's thicker and it's more difficult to work with. Now, fiber optic cable is different because it doesn't send electric impulses down the wire, it sends light beams down the wire. And as you know, the speed of light is faster than the speed of electricity. Fiber optic cable gives us much greater bandwidth. It's totally insusceptible to electromagnetic interference because electrons don't go down the wire. Light beams go down the wire. So you could run it right past a big old generator and that would still not corrupt the signal on the wire. And fiber optic cable goes a much, much greater distance than either twisted pair or coaxial cable. If we cut open a fiber optic cable, there is the sheathing, and this fluffy stuff here, it's just rope to give it strength. The real fiber optic cable are these fine little wires here that look like they're about the thickness of a pin, and they carry the light beams down the wire. Fiber optic comes in both multi-mode and single mode. For short distance, for example, to connect a switch to a switch, you would use the multi-mode. And when they say short distance, they're talking about 2 kilometers. And single mode fiber is used for longer distance, and we're talking about 100 kilometers for single mode fiber. We use multi-mode fiber here at CCBC because we just use it to connect the switches and the buildings together. Fiber optic is typically used as a backbone technology, and when we say backbone, we mean the wires that connect the switches to the switches and the buildings to the buildings. Typically, you don't use fiber to the workstations. Typically, the workstations would just use regular Ethernet twisted pair cabling. You could use fiber to the workstations, but it's usually not necessary. Be a lot more expensive. Typically, fiber is used as a backbone to connect switches together. If we look at the different type of fiber optic connectors, this is an SC connector, square connector, and this is an ST, a straight tip connector. If we compare fiber optic to coaxial to twisted pair, we will see that fiber optic has by far the greatest bandwidth and by far the greatest distance. It is totally insusceptible to electromagnetic interference, but it costs a lot more and it can be complicated and expensive to install. On the other end of the spectrum, you have twisted pair. It doesn't have the bandwidth of fiber optic, but it doesn't really need it because it's only connected to one individual workstation. The cable length is only 100 meters. It is susceptible to electromagnetic interference, but if you're doing it in an office, there are not going to be a bunch of generators lying around which are going to cause electromagnetic interference. It is much cheaper. You can buy the stuff at Walmart, and it is very easy to install. And then coax falls somewhere between the two. What is a distribution rack? If you don't have a distribution rack, you put the switch right in the middle of the office, sitting on the floor or on a table, and you run the cable to each workstation, and then everybody trips over the wires. A more professional way to go would be to use a distribution rack. A distribution rack is an aluminum rack as tall as a person is, and the distribution rack contains the switch, it contains the router, and it can contain the servers. And then the workstations over here their patch cable plugs into a wall jack which goes through the wall and then connects to the distribution rack, which is in the telecommunications closet. A distribution rack is a much more professional way to go. Now let's look at wireless networking technologies, and we can see that wireless falls into 4 general categories, some which we use more than others: radio frequency, infrared, laser, and microwave. Now, I think everybody understands the concept of radio frequency. Radio frequency is what's used by police radio. It sends radio waves through the air. And radio frequency is the same technology that's used by Wi-Fi in our wireless local area networks. Another technology is infrared, and It's a wireless technology that everybody uses with their garage door opener or with their TV remote control. And computers used to use infrared, but now they all use radio frequency. You don't really see computers using infrared anymore. And then another wireless technology is called laser. Now this first picture is not a laser beam, that is a flashlight. Notice that the beam spreads out as it gets farther away and it gets weaker and weaker. A laser beam does not spread out. It stays straight, and therefore the signal stays strong for a much greater distance. Laser is often used to connect buildings together to create wireless bridges. So here's the situation. We have two buildings which are separated by a highway, and we want to connect the buildings together, and we can't dig under the highway. So one thing we could do is we could run a wire between those buildings, and then we would have connectivity between the two buildings. And then all the traffic could go under the wire. And if a truck went under the wire, it wouldn't be a problem because it wouldn't hit the wire. And if the circus came to town and a lion cage went under the wire, it wouldn't hit the wire. But if this circus had a giraffe, then that giraffe could potentially hit the wire and break the wire. Or maybe not a giraffe, perhaps just some sort of big commercial vehicle like a crane. The point is that if you have outside wires, it becomes an obstruction, and it could be hit or knocked down by any traffic that is going under that obstruction. So the solution would be to use laser technology. What we do is we create a wireless bridge that connects the two buildings together. On one building, we have a laser device which sends a laser beam across to the other building. The laser beam goes across to the other building, and that carries the network traffic from the computers in this building to the computers in this building. And then the other building has a wireless device as well, which receives the signal from the other building. Wireless technology is commonly used with wireless bridges if you're running over a highway and you don't want to cause an obstruction. And another technology, a fourth wireless technology, is called microwave. And if you look at this tower right here, this is what is on the top of our library at CCBC. In fact, we have a microwave tower on top of the buildings at Catonsville and Dundalk and Essex, and they're all hooked together that way, so in case our Comcast connection goes out, we can still all communicate with each other using microwave. Microwave uses high frequency and high bandwidth. And when we say terrestrial microwave, we mean tower to tower. And microwave uses line of sight, so the towers can be just so far apart due to the curvature of the Earth. Due to the curvature of the Earth, if you want to communicate a long way from one microwave tower to the other, since it's line of sight, you have to have a string of microwave towers to overcome the curvature of the Earth. Now, another way to overcome the curvature of the Earth is just to use a geosynchronous satellite. And that allows for us to have microwave connections at parts of the globe which are far apart and which cannot easily be connected with microwave towers. Chapter 4, Summary. In this chapter, we looked at methods of connecting computers, both bounded and unbounded. Types of cable include twisted pair and coax, and they both fall into the category of copper. And then fiber optic uses light beam, so it's much faster and it's insusceptible to electromagnetic interference. And there are different wireless technologies. Radio frequency is used by police radio and is also used in our regular Wi-Fi networks. Infrared is not so much used anymore. Laser can be used for a wireless bridge, and microwave gives us high frequency, high bandwidth connectivity. And this concludes Chapter 4. Thank you very much, and have a nice day.